Yes, electrical service can exist after the main disconnect. This is a common configuration, particularly in commercial and industrial facilities, where you'll find multiple meters and distribution panels situated downstream from the main disconnect. The primary role of the main disconnect is to provide a means of isolating the entire facility from the utility's electrical grid. Following the main disconnect, you'll find meters and distribution panels that are designed to supply power to specific sections or areas within the building or facility. In such scenarios, the electrical service is defined as that portion of the electrical system that lies downstream of the main disconnect but upstream of the individual meters. This encompasses all the distribution panels, the associated wiring, and any other electrical equipment that plays a part in distributing power throughout the facility. The assertion that meters are a prerequisite for a service is inaccurate. Meters are simply devices used to quantify electricity consumption. They are not essential for the actual delivery of electrical power. A service can certainly exist independently of meters, but it fundamentally requires both the source of electricity and a means of distributing that electricity. Therefore, the concept of a service existing after the main disconnect is not only possible but also frequently encountered in commercial and industrial environments. To delve deeper into this topic, let's consider the components that typically constitute an electrical service. Firstly, there's the service entrance, which is the point where the utility's electrical supply connects to the building's electrical system. This service entrance usually includes service entrance conductors, which are the wires that carry the electricity from the utility's transformer to the building. Secondly, we have the main disconnect, which, as previously mentioned, serves as the primary means of isolating the entire electrical system. This is crucial for safety during maintenance or emergencies. Thirdly, you'll find distribution panels, which are also known as panel boards or load centers. These panels receive power from the main disconnect and distribute it to various branch circuits throughout the facility. Fourthly, branch circuits are the individual circuits that supply power to lights, receptacles, equipment, and other electrical loads. Each branch circuit is protected by a circuit breaker or fuse within the distribution panel. Fifthly, meters are installed to measure the amount of electricity consumed by different parts of the building or by individual tenants. This is essential for billing purposes. Sixthly, grounding is a critical aspect of any electrical service. A proper grounding system ensures that the electrical system is safely connected to the earth, providing a path for fault currents to flow in the event of a ground fault. This helps to prevent electrical shock hazards. Now let's consider how these components are arranged in a typical commercial or industrial setting where there is a service after the main disconnect. The utility's service entrance conductors enter the building and connect to the main disconnect. From the main disconnect, the power is fed to one or more distribution panels. These distribution panels may be located in different parts of the building to minimize voltage drop and to provide power to specific areas. Each distribution panel may have one or more meters associated with it. These meters measure the electricity consumption of the circuits fed from that panel. For example, in a shopping mall, each store might have its own meter to measure its electricity usage. Similarly, in an office building, each tenant might have its own meter. The key point to remember is that the service is the entire electrical system downstream of the main disconnect, including the distribution panels, meters, wiring, and other equipment. The meters are simply devices used to measure electricity consumption, and they are not essential for the existence of the service itself. Now, let's address some common misconceptions about electrical services and meters. One common misconception is that the service is only the portion of the electrical system upstream of the meter. This is incorrect. As we have discussed, the service includes everything downstream of the main disconnect. Another misconception is that meters are required for a service to exist. This is also incorrect. A service can exist without meters, although it is common to have meters for billing purposes. Another important concept to understand is the difference between a service and a feeder. A service is the portion of the electrical system that receives power directly from the utility. A feeder is a circuit that carries power from the service equipment to a subpanel or other distribution point. Feeders are typically used to extend the electrical system to different parts of a building or facility. Feeders are downstream of the service equipment, and they are not considered part of the service itself. The National Electrical Code, or NEC, provides detailed requirements for electrical services and feeders. The NEC defines the service as the conductors and equipment for delivering electric power from the serving utility to the wiring system of the premises served. The NEC also specifies the types of wiring methods, overcurrent protection, and grounding requirements for services and feeders. When designing or installing an electrical service, it is essential to comply with the NEC and any local codes or regulations. This will ensure that the electrical system is safe and reliable. Here are some additional points to consider when dealing with electrical services after the main disconnect. Firstly, coordination of overcurrent protection is crucial. Overcurrent protection devices, such as circuit breakers and fuses, must be properly coordinated to ensure that a fault on one branch circuit does not trip the main disconnect. This requires careful selection of the size and type of overcurrent protection devices. Secondly, voltage drop calculations are important. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Therefore, it is important to calculate the voltage drop in the service conductors and feeders to ensure that it is within acceptable limits. Thirdly, labeling is essential. All electrical equipment, including distribution panels, meters, and disconnects, must be properly labeled to identify their function and the circuits they serve. This is crucial for safety and for troubleshooting purposes. Fourthly, regular maintenance is necessary. Electrical services should be inspected and maintained on a regular basis to ensure that they are operating safely and reliably. This includes inspecting wiring, tightening connections, and testing overcurrent protection devices. Fifthly, documentation is important. Accurate documentation of the electrical service, including wiring diagrams, panel schedules, and equipment specifications, is essential for future maintenance, repairs, and upgrades. Now let's delve into some specific scenarios where you might encounter a service after the main disconnect. Imagine a large industrial complex with multiple buildings. Each building might have its own distribution panel and meter, but the entire complex is fed from a single service entrance and main disconnect. In this case, each building's distribution panel and meter would be considered part of the service. Consider a high-rise office building with multiple tenants. Each tenant might have its own meter to measure their electricity consumption. The entire building is fed from a single service entrance and main disconnect. In this case, each tenant's meter would be considered part of the service. Think of a shopping center with multiple stores. Each store might have its own meter to measure its electricity consumption. The entire shopping center is fed from a single service entrance and main disconnect. In this case, each store's meter would be considered part of the service. Visualize a university campus with multiple buildings. Each building might have its own distribution panel and meter, but the entire campus is fed from a single service entrance and main disconnect. In this case, each building's distribution panel and meter would be considered part of the service. Envision a hospital complex with multiple buildings. Each building might have its own distribution panel and meter, but the entire complex is fed from a single service entrance and main disconnect. In this case, each building's distribution panel and meter would be considered part of the service. In all of these scenarios, the key is that the service is defined as the portion of the electrical system downstream of the main disconnect and upstream of the individual meters. The meters are simply devices used to measure electricity consumption, and they are not essential for the existence of the service itself. It's also important to consider the implications of having a service after the main disconnect for metering and billing purposes. In many cases, the utility company will install a master meter at the main disconnect to measure the total electricity consumption of the facility. The individual meters downstream of the main disconnect are then used to allocate the total electricity consumption among the different tenants or departments. This requires careful coordination between the utility company and the building owner or manager. It's also important to ensure that the meters are accurate and properly calibrated. Regular meter testing and calibration may be required to ensure accurate billing. In some cases, the building owner or manager may choose to install their own submeters to further break down the electricity consumption among different areas or departments. This can provide valuable information for energy management and cost allocation purposes. The NEC provides specific requirements for metering and submetering in Article 220. For example, the NEC requires that metering equipment be accessible and that it be protected from damage. The NEC also specifies the requirements for the wiring and installation of metering equipment. In addition to the technical aspects of services after the main disconnect, it's also important to consider the legal and regulatory aspects. Local codes and regulations may impose additional requirements for electrical services. For example, some jurisdictions may require that all electrical work be performed by licensed electricians. Other jurisdictions may require that electrical services be inspected and approved by a local authority. It's essential to comply with all applicable codes and regulations to ensure that the electrical service is safe and legal. Non-compliance with codes and regulations can result in fines, penalties, and even legal action. Therefore, it's always best to consult with a qualified electrical engineer or contractor to ensure that your electrical service complies with all applicable requirements. Let's consider some common issues that can arise with services after the main disconnect. One common issue is voltage drop. As we discussed earlier, voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. This is especially problematic in large facilities with long feeder runs. To mitigate voltage drop, it's important to use conductors that are large enough to carry the required current without excessive voltage drop. The NEC provides tables that can be used to determine the appropriate conductor size for a given current and distance. Another common issue is overheating. Overheating can occur when electrical connections are loose or corroded, or when equipment is overloaded. Overheating can damage equipment and even cause fires. To prevent overheating, it's important to ensure that all electrical connections are tight and clean. Regular inspections should be performed to identify any signs of overheating. If overheating is detected, the cause should be investigated and corrected immediately. Another common issue is ground faults. A ground fault occurs when an electrical conductor comes into contact with a grounded surface. Ground faults can cause electrical shock hazards and can also damage equipment. To prevent ground faults, it's important to ensure that all electrical equipment is properly grounded. Ground fault circuit interrupters, or GFCIs, should be installed in areas where there is a high risk of ground faults, such as bathrooms and kitchens. Another common issue is nuisance tripping of circuit breakers. Nuisance tripping occurs when a circuit breaker trips for no apparent reason. Nuisance tripping can be caused by a variety of factors, including overloads, short circuits, and ground faults. To troubleshoot nuisance tripping, it's important to first identify the cause of the tripping. This may require the use of a multimeter or other testing equipment. Once the cause of the tripping has been identified, the appropriate corrective action can be taken. For example, if the tripping is caused by an overload, the load on the circuit may need to be reduced. If the tripping is caused by a short circuit or ground fault, the fault must be located and repaired. To summarize, having a service after the main disconnect is a common and acceptable practice, especially in commercial and industrial settings. The key takeaway is that the service encompasses all electrical components downstream of the main disconnect, regardless of the presence of individual meters. Meters are simply measurement tools and do not define the extent of the service. Understanding this distinction is crucial for proper design, installation, maintenance, and billing of electrical systems. Always consult with qualified professionals and adhere to relevant codes and regulations to ensure safety and compliance.